So in this lecture, let's talk about introductions to complex numbers and conjugate pairs, okay? Now, before I get into that, I just want to talk about numbers in general. So we have on top of the chart, we have complex numbers, and underneath that, we have the real numbers and the imaginary number. Imaginary. Okay, and underneath the real number, we have rational, and oh, let me write that properly. We have the rational number and the irrational number. Irrational. So let's talk about the real part first. So the real part of the complex number consists of the rational and irrational numbers. So underneath the rational numbers, we have things like integers, and then we have whole numbers, and then finally we have the natural numbers. Natural numbers. Okay, so these are fractions, so these can be expressed in fractions, so like that. Whole numbers are 0, 1, 2, 3, and then natural numbers are just 1, 2, 3. So they don't include zeros, okay, in the natural numbers. And irrational numbers are things like surds, okay, and often they have like radicals. So things like, for example, negative 3 to the square root, or minus 2 plus or minus 5 over 2. So these are the irrational numbers where they can't form fractions. So can't form fractions. Okay, now that's the real part. Now the imaginary part. So this is the square root of a negative number. Okay, so square root of negative 1 is equals to I. Okay, now the square of I is equals to negative 1. Okay, so always remember that. Always remember that. Okay, so that's the whole tree of complex numbers, and complex numbers consist of course, the real number plus the imaginary number. Okay, which is a plus bi. Okay, now let's talk about the conjugate pairs. So the conjugate pair is when, say for example, you have z is equals to 3 plus 4i, where my real number is 3 and my imaginary number is 4. Okay, now the conjugate, we denote conjugate as z to a bar, so this is the bar, so z bar is equals to 3 minus 4i. Okay, now the only difference between the original and the conjugate pair is just the sign change in the imaginary part. Okay, so it's just always the sign change. Okay, so we don't do anything to the real part, we only change the sign in the imaginary part. So for example, if I have w equals to negative 3 minus 5i, then w bar is equals to negative 3 plus 5i. Okay, now conjugate pairs are really important. They can be used to rationalize a denominator. Okay, so for example, if I have 3 plus 4i equals to 3 minus 4i. Okay, now in any case, we should not have a complex number down in the denominator. Okay, so what we must do is that we have to times the conjugate pair, which is 3 plus 4i over 3 plus 4i. Now the reason why we do that is because this whole thing here, that is just equals to 1, right? Because the numerator equals the denominator. Okay, so when we solve this, there will be 3 plus 4i square, yeah, over 3 minus 4i, and then 3 plus 4i. Okay, now one very neat trick that you can do is that whenever you have difference uh, in the if you have the same number but different sign for a complex number, you can go, okay, so a plus bi and then multiply by a minus bi. That is actually equals to a square plus b square. Okay, now it's plus. Okay, remember it's plus. Now if we don't have the I, we would have a plus b, a minus b, so that will be a square minus bi, minus b square, sorry. So remember the difference. when you have I when you have I, or the imaginary part, it's plus. When you don't have the imaginary part, it's minus. Okay, so let's go ahead and solve this. So that will be equals to uh, 9, and then plus 8i, and then plus 4i square. Okay, over 3 square plus 4 square. Okay, so that will be 9 plus 8i plus, so 4 square is 16, negative I square is -1 multiplied by -1 over, so we have 9 plus 16. Okay, so that will be 9 minus 16 plus 8i over 25. So that will equals to -5 plus 8i over 25. Okay, guys, so conjugate pairs are really important, also when you're solving roots, okay, which we'll talk about in the later lectures. So again, if you guys have any questions at all, feel free to drop me a message in the discussion board, and I'll get back to you as soon as possible. Okay, guys, so I'll see you guys in the next lecture.